All the new modalities you mentioned have one thing in common, that they are more shear sensitive than, for example, bacteria or CHO cells. And orbital-shaken bioreactors are very suitable for shear sensitive cells or systems. And the main reason is that they are surface aerated, meaning we have nearly no bubbles. And bubbles are rising, they are bursting, they are creating very high local power input when they burst, and this will damage the cells.
Welcome back. In part 1, Tibor Anderlei walked us through the hidden physics of shake flasks and microtiter plates, and why reproducibility challenges are so often rooted in fundamentals that get overlooked, such as the shaking diameter. Now, in part 2, we continue our conversation and go deeper, exploring next-generation modalities, cultivated meat, and the surprising range of fields where shaking technology is making an impact beyond bioprocessing. Plus, leadership lessons from 3 decades in the industry. Let's continue. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist Podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech.
I would like to dive a bit deeper into the aeration, since you mentioned that this is one of the pitfalls that people work in oxygen-limited conditions. One way to measure the aeration is by the dissolved oxygen, like in bioreactors, for instance. Can you tell us what the best way is? Is DOE sufficient, or should you do more sophisticated measurements? What is your recommendation there?
It's a little bit questioned what is the difference between DO, for example, or another parameter. And in my opinion, the other parameter is the oxygen transfer rate and the carbon dioxide transfer rate. Because I hear very often that the people say, yeah, I have DO, why should I have OTR and CTR, for example? And I always compare it with a bathtub. So the water level is the concentration and DO is the concentration. And the change of the water level over the time is a rate, and that is the oxygen transfer rate. And with the rate, you can tell that the water level is increasing, decreasing, or stays stable. So you have a view into the future. You can ask yourself the question, what would you like to know when you are leaving the house for 5 minutes and you are filling your bathtub? And I think, or I assume you agree, that the rate is much more important than the level of the water, than the DO. And furthermore, the advantage of measurement of the respiration activity, like oxygen transfer rate and carbon dioxide, that you can measure outside of the sterile boundary of your bioreactor. So you do not have any contamination risk compared to sensors measuring inside the bioreactor broth. And last but not least, or furthermore, the respiration quotient between CTR, so carbon dioxide transfer rate, divided by the oxygen transfer rate, gives you also an information which carbon source is consumed. For example, RQ around 1 means glucose, RQ around 0.6 means, for example, ethanol. And you can start to balance a bioprocess, which is, of course, very interesting for metabolic flux analysis, for example. And last but not least, if you want to compare different bioreactors systems steered to a shake flask, to a wave, you cannot do that with a DO value. You cannot compare them, but you can compare the bioreactors by using oxygen transfer rate. So I think OTR and CTR are much higher valuable parameters than, for example, DO.
And what is the minimal scale you need to work in order to measure the oxygen transfer rate or the CO2 transfer rate?
Nowadays, the OTR, we are capable to measure in microtiter plates. We have a system, it's called microtom. So we measure the OTR in each well of a 96 well deep well plate. So that's the minimum already. And maximum is huge bioreactors. More or less, I would say, in the microbial world, it's more or less standard. Since decades, they are already measuring OTR, CTR, control bioreactors with OTR, CTR. But in the cell culture world, it's not as a standard as in the microbial world, I would say.
Yeah, I agree. I haven't seen that so much when I was doing microtiter plate experiments or spin tube experiments. People talk about it in bioreactors, I'd say in the cell culture world, but it's good to know that you have the possibility to do that at a much smaller scale. I would like to touch upon PAT as well, because there's many people using microtiter plates to measure all kinds of parameters, hopefully even in real time or at least in semi-real time. What is the situation there? What kind of PAT are you developing or you see companies using at that very small scale already?
Maybe microtiter plate, I would also put a shake flask into that. I think it's very relevant at the end, of course, to have a PAT already on the small scale, because I still have the feeling that monitoring online the pre-culture for bigger bioreactors is still not carried out very often. And during the time at AC Biotech, for example, we carried out a lot of Pichia pastoris cultivation in steered bioreactors. And we were very often confronted that the runs in the steered bioreactor were not very reproducible. And of course, first we always looked on our main culture, which was in the steered bioreactor, and we tried to optimize it. But then we learned that the reason for the unreproducible runs in the steered bioreactor comes from a not reproducible pre-culture. And we learned the lesson and changed the transfer criteria, which was OD by sampling. When you know Pichia, they get to very high ODs. It's not so easy to determine ODs. To oxygen transfer rate by an online signal. So we transferred then always at the OTR of, for example, 0.03 mole per liter in hours. And that led to our wished result. So in my opinion, the history of the pre-culture is really, really important. And to be honest with you, I still have the feeling that even now, with the topics of modeling and digital twin, even there, the condition of the pre-culture is still not paid too much attention to, in my opinion.
Yes, I fully agree. The pre-culture is extremely important. I would like to talk about other modalities, because these systems have traditionally been used in the microbial space and in, I'd say, CHO or mammalian cell culture. Now we're seeing viral vectors, CAR-T, mRNA. We also see cultivated meat. How is the landscape changing or the technology evolving? What are you seeing among your different customers?
For me, it's a little bit easier, I would say, because on the shake flask level, I do not see so many differences, because all the new modalities you mentioned have one thing in common, that they are more shear sensitive than, for example, bacteria or CHO cells. And orbital-shaken bioreactors are very suitable for shear sensitive cells or systems. And the main reason is that they are surface aerated. meaning we have nearly no bubbles. And bubbles are rising, they are bursting, they are creating very high local power input when they burst, and this will damage the cells. So I see no huge change on the shake flask level. And furthermore, again, real-time monitoring is always good. When you want to establish a new biological system in your lab, you are much faster in analyzing and you're optimizing your screening or cultivation conditions much faster. And furthermore, the online data will support you to reduce the amount of offline samples because you take samples, how I always call it, at the point of interest. When, for example, the online signal like OTR will suddenly show a dip, then you take a sample. Less samples means less time for analysis and, of course, less cost. You also mentioned the new cultivated meat area or field. I see there are also not so many differences in the shake flask scale or small scale. The one thing is, of course, that the food industry is very price-sensitive market regarding media and production equipment. So a lot of workforce is focused on the development of a good and inexpensive media, as there is also a time pressure for these companies. Media testing have to be parallelized, in my opinion, and therefore it will be shifted into microtiter plate scale very, very early. And investing here also in online technology will speed up the process tremendously. And also because the market is so price sensitive, also expensive consumables like special flasks or special plates is not a topic in the field because of the money. So that's why for us, when we developed our system like the Kühner Tom or the microtom, we always use standard plates and standard shake flasks to keep the running cost for the customer low. And I think that is key for this area also.
Besides cultivation for cell culture processes, do you also see people using your systems for other applications at all? Can that be used in different areas we have not touched upon yet?
Oh, yeah. We have a lot of different customers in that field. So let's say one field is, for example, just mixing. Because when you use Orbital-shaker for mixing, you use always closed systems. So the bag can be closed compared to if you want to mix it with a stirrer, you have to open it and put a stirrer inside. So by using a shaker, you can mix closed system, biggest advantage. So for example, we have one customer, quite a huge company in the Asian region, who is using our system for liquid crystal mixing. So only liquid crystals for your mobile phone, for TVs and so on. So a totally other market. And we see also quite often now that customers are using our system for storage. So for example, if they have a fermentation broth with cells inside and they want to store it, but they also have to mix it meanwhile. We have customers who do that, but it's manual made. They go in a cold room, shake the bags, and then they go out. But that is not a defined way. So here they use it also. For example, when it comes to, in general, thawing technology, so thawing fermentation broth, this has to be thawed also in a very defined way. And here our systems are also very popular, I have to say.
That's exciting because that's what people think about at first when you talk about shaken bioreactors and microtiter plates. It's interesting that it's so wide.
Yes, definitely. Yeah.
I would like to circle back to your entrepreneurial endeavors. We talked about this at the very beginning of our conversation. You founded a startup, you founded AC Biotech, and now you've been with Kühner for 2 decades. I would love to just hear your perspective because now at Kühner, you're competing with a lot of bigger players in the space, not to mention the big ones, Sartorius, Cytiva, or Thermo Fisher. What have you learned working as an entrepreneur, as a leader, in order to not only survive in that very dynamic market, but actually thrive?
That is a mixture of questions. So first of all, yes, you have the field where Sartorius, Cytiva and Thermo are our competitor. So we as Kühner right now, we have to be innovative, definitely, and we have to be agile. That is also. And I think we have to be very near to our customers. And I think that is one thing where we as Kühner are quite good at. And on the one hand, of course, we have kind of competition with Sartorius and Cytiva and Thermo, the big players. But on the other hand, they are also our customers because they merge with or bought companies which were already our customers. So there's always this two sides. And to be honest, I hope that the pharma and biotech companies also want to be in the future flexible and independent regarding their suppliers. So there's always a chance for us as a small or mid-sized company to compete with the global players. And I think one thing, it's the Corona time should have taught us this lesson, I have to say.
Yes.
To have different suppliers at the end. Yeah.
At least dual sourcing is a pretty good idea.
Mm-hmm.
This leads me to the next question, because I would love to hear about your leadership experience and understand what is your most important leadership lesson that you have learned about building successful technical organizations in biotech.
Okay, of course, I had experience with a startup, and then maybe I'm boring because I went also to one other company, Kühner Shaker, and since 20 years I'm there. But from my experience, so in my opinion, when you launch a company, you should always have a product idea in mind. Being only a service provider in the beginning is good to generate fast a cash flow, which is needed, but you should always have also at this time have a product in mind, which you also use this time to develop this kind of product. And a second thing I would say is that you should learn to hear more on your gut feeling. You have, of course, to analyze as much as you can before you make a decision. But you cannot analyze everything. That's not possible. And also, a complete analysis needs a long time. And mostly, from my experience, it doesn't influence the final decision very much. And third, I would say that I have underestimated at the beginning the importance of the personal chemistry between business partners. A good relationship between business partners is a very important factor for successful cooperation. And second, which is also very important for me because I like it very much, in general, I like to say that I'm glad working in the field of biotechnology because you nearly always work together really with very nice people.
Yes, I agree. Biotech is a nice place to work at. I've met a lot of nice people along my career.
Definitely, yeah.
As we are landing this plane, Tibor, I would like to make it very actionable for the Smart Biotech scientists listening. What is one piece of advice you would give them as they are either starting out using microtiter plates, shake flasks, or they're making it work? What is the one thing they should do?
You know, I love shaking diameter, but that is the one thing. But I would say, please perceive the importance of the shaken bioreactor and determine the screening conditions you're applying very thoroughly. And furthermore, I would always suggest to use also online measuring tool for the small scale bioreactors. I think that is also key. You are using online 1 liter upwards, but not very often for the small scale.
Fantastic. Before we wrap up, Tibor, what burning question haven't I asked that you are eager to share with our biotech community?
I think you asked already quite a lot of questions and important questions. We really fully did everything. Maybe at the end, I would also give them important take-home message, in my opinion. So if a shaken bioreactor like shake flask or tube microtiter plate is applied correctly, you will have an easy to handle, an inexpensive and automatable tool with low running costs, providing scalable results. So I think this is a key take-home message, and which wraps up also a little bit what we discussed before. So the knowledge is really important on the small scale. And I hope that also in universities, they learn also that this topic should be taught. And by the way, we have also a nice webinar on this topic, which you also can find on our website, where my colleague David Flitch, over 6 sessions, he explains how to handle microtiter plates, tubes, and shake flasks the right way.
There you got it, Smart Biotech Scientist. That's a great take-home message. Thank you, Tibor, for highlighting that. Shaken bioreactor system can be a very powerful tool. Where can people connect with you and also use the webinars or resources you have? Where can they get that information?
So, of course, you can reach me via LinkedIn. And I think a lot of people can meet me at conferences and trade fairs. Also my team, of course. We have always a booth with the rings in the logo. You cannot fail to see it. And the rings, by the way, standing for the orbital movement, because we are doing orbital shaking. That's why we have the rings in our logo. And I think the easiest way is via LinkedIn, in my opinion.
Fantastic. I will put the links in the show notes, so please use this opportunity, Smart Biotech Scientists, to reach out to Tibor and his team. And Tibor, thank you once again for sharing your passion for this field and for giving us a ton of advice and also practical insights. Thank you again for being on the show today.
Thank you very much, David, and looking forward maybe to the next podcast.
Absolutely.
See you. Bye-bye.
Tibor Anderlei's combination of scientific rigor, entrepreneurial experience, and frontline customer work makes him a rare voice in this space. Whether you're troubleshooting a scale-up or preparing documentation for a CDMO transfer, today's conversation gives you a sharper framework to work with. Thanks for listening to the Smart Biotech Scientist Podcast. If this episode was useful, please leave a review on Apple Podcasts or your favorite platform and share it with a colleague. Thank you so much for tuning in today, and I'll see you next time. All right, smart scientists. That's all for today on the Smart Biotech Scientist Podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.